Well, we've just studied some linear inequalities. That's where the power of x is equal to 1. Let's take a look at some nonlinear inequalities now, where the power of x gets bigger than 1, or where perhaps we have some quotients of factors of x. Now, recall when we went to nonlinear equations, like quadratic equations, one method we had for solving was factoring. In factoring, we use something called the zero product theorem. That is, we made a zero on one side of the equation, and then by factoring, we made a product on the other side of the equation, and we said if that product was equal to 0, then either the first factor was equal to 0 or the second factor was equal to 0, and that gave us our solutions. Is there something similar for nonlinear inequalities? Well, let's see. Here's the same problem, but instead of an equal to, it's a less than. So that makes it an inequality. It's quadratic, so it's nonlinear. Let's see what happens when we solve that. If I move 8 to the other side like I did in the factoring, I get x squared minus 2x minus 8 is less than 0. If I factor it into x minus 4, x plus 2 is less than 0. Can I then say x minus 4 is less than 0 or x plus 2 is less than 0, and then x is less than 4 or x is less than negative 2? Now, or means that a solution is any number that would either be less than 4 or less than negative 2. Well, negative 6 is a number that's less than 4 or less than negative 2, and if I plug negative 6 in here, I get negative 10 times negative 4, which is positive 40, which is actually bigger than 0. So the same technique that we tried to use here, we can't use over here. It leads us to false answers. So what can we do? Well, it's quite a bit more complicated process to solve a nonlinear inequality than it is to solve a linear inequality, but I've written out here the steps to do it, and I'll give you a quick example. In fact, we'll use this exact same problem as our example. We'll see how we really do come to a conclusion. Remember, that conclusion, based on the same reasoning we used for the zero product theorem problems of equalities, did not work. It left us with a wrong answer. So let's take a look at the rules here. We want to solve x squared minus 2x is less than 8, and it says to solve nonlinear inequalities, get a product on one side and a 0 on the other. Well, we did that up here, so let's just recopy what we had there. First, of course, we moved the 8 over here, remember. Then we had x minus 4 times x plus 2 is less than 0, so I've got a product, first bracket times second bracket on the left, and a 0 on the right. It says, identify the critical numbers, numbers which cause any factors to become 0. So I'm going to identify my critical numbers. Now, critical numbers are numbers which cause factors to become 0. When you multiply things together, like x minus 4 times x plus 2, that x minus 4 and x plus 2 are called factors. Now, what value of x would make x minus 4 0? Well, that would be 4. And what would make x plus 2 0? That would be negative 2. So it says identify the critical numbers, so I've got 4 and negative 2, and graph them on the number line. So I'm going to make a number line here. Put 0 in the middle. Mark negative 2 off on the left. 4 on the right, and to graph them, I think I'll just make them heavier. So there's my negative 2 and there's my 4. Now, it says use the critical numbers to break the number line into distinct intervals. Well, if you've got two critical numbers, you make three intervals on the number line. The first interval is the interval out this way. That would be negative infinity to negative 2. And these are open intervals that we're talking about. The next interval would be negative 2 to 4. And the next interval would be 4 to infinity. And so two critical numbers break the number line into three intervals. Negative infinity to negative 2 brings us up to here. Negative 2 to 4 brings us up to here. And it contains the number 0. And then 4 to infinity starts here at 4, goes all the way out to infinity. It says check one number interior. Interior means not at an endpoint. So if I was checking a number in the interval negative 2 to 4, I wouldn't use negative 2 and I wouldn't use 4. Those are endpoints. Those numbers would not be interior to the interval. It says check one number interior to each interval. So I'm going to have to check a number here, negative infinity to negative 2, check a number here, and check a number here. To find your solution intervals, okay? I'm just going to grab a number here. One number that's in this interval would be negative 3. And what I'm going to do is I'm going to take this, write it with empty holes, and if I find a solution interval, then this negative 3 will have to be a solution. And if it is, that's going to tell me that negative infinity to negative 2 is a solution interval. Okay, I try in negative 3. If I put a negative 3 here, I get negative 7. If I put negative 3 here, I get negative 1. Negative 7 times negative 1 is positive 7. Positive 7 is not less than 0. So this value negative 3 did not make this a true sentence. Therefore, this is not a solution interval. Okay, let's try another one. I'll just erase this first attempt. Now this time my interval is negative 2 to 4, and I'm kind of lucky because in this interval is 0, and that's really easy to check. Put a 0 here, put a 0 here. 0 minus 4 is negative 4 times. 0 plus 2 is positive 2. Negative 4 times positive 2 is negative 8. Negative 8 is less than 0. So this gave me a true sentence, so this is going to be a solution interval. So I'm going to write down my first solution interval, negative 2 to 4. Now I need to check a number from the third interval. The third interval goes from 4 to infinity. Somewhere out here is 10. I'm going to check 10. So let me erase this. Instead of a 0 here, I'll put a 10 here. 10 minus 4 is 6. 10 plus 2 is 12. 6 times 12 is positive. So that's going to be greater than 0. In order to make the sentence true, it had to be less than 0. So that's not a solution interval. So I've got the solution interval negative 2 to 4. Now one comment. If this, instead of being less than, had been less than or equal to, then my solution would have been negative 2 to 4 with square brackets rather than round brackets. And that completes the podcast.